Assalamu alaikum. Welcome to this online lecture series of data mining. In this lecture of association rule mining, I'll try to explain the working of FP growth algorithm or frequent pattern growth algorithm. We'll solve an example of transactional database in order to mine frequent items or frequent patterns from transactional database using FP growth algorithm, and then we'll generate association rules from the mined frequent items. So let's start the example. Here we have the same data set that we have solved in our previous example of the a priori algorithm. This data set is the all electronics transactional database, which contains 9 transactions, the transaction ID 100 to transaction ID 900, and each transaction contains different item sets. Like the transaction 100 contains A, B and E as item sets. Similarly for 200 transaction ID, it contains B and D as item set. So similarly for all other transactions. So the problem is we have to generate FP tree to find frequent item sets for the following transactional dataset. So here we have the same transactional dataset of all electronics, and suppose the minimum support threshold is 2. So in first scan, if you remember the our last lecture of FP growth algorithm, in which we have explained the working of the FP growth algorithm, like in first step we have to scan the database and generate the frequent one item sets, and then the second point or second the second point of the FP growth is we have to arrange the frequent item sets into their descending order of their support count, and in the third scan we and in the third point of the algorithm we have to generate the header table, which contains the item sets with their decreasing order of their support count, and then we have to generate the frequent pattern tree from the header table, and from the frequent pattern tree we have to generate the conditional pattern basis, and from the conditional pattern basis we can mine the frequent item sets. So we apply those concepts that we have discussed in our previous lecture on this example. So here we have the transactional database or transactional dataset, and the minimum support for this example or for this case is 2. So according to the first point or first first we have to generate the frequent item sets of length 1. So in this database we have, you can see A occurs 6 times as A in first transaction, in 4th, 5th, 7th, 8th and 9th transaction. So it occurs 6 times. Similarly, item set B occurs 7 times in this transactional database, C occurs 6 times, D occurs 2 times and E occurs 2 times. So in this transactional database we have A, B, C, D and E, only 5 items. So you can see all the 5 items are frequent one item sets. So there is no item that we can remove because our support is 2. So all the items in these transactions occurs minimum 2 times. So all the items are frequent one item sets. So from this frequent one item set, we have to generate these items into the descending order of their spot count. So like B occurs 7 times, so it has maximum spot count of 7, so we place it at the top of the table. Then we have to place the item set that has spot count of less than 7, so which is A6, then C6, C with spot count of 6, and D with spot count of 2, and E with spot count of 2. So you may have a question like A and C have same spot count. How can we place only A at the top and C at the bottom of A? So it's your choice. You can place C first and A after C, so it doesn't matter. So after that, according to this the order, we placed or ordered these item sets into descending order of their frequency or spot count. So according to this table, we can order these item sets. Like B has 7 spot count, so it occurs first, then A with 6 and E with 2. So it is the ordered representation of these item sets of transaction ID 100. Similarly, for transaction ID 200, we have B spot count, which is 7, and then we have D, so it's already in ordered shape. Then BC already in the same sequence. So for transaction ID 400, we have A, B, D. So A's spot count is less than B, so we place B first, then we place A, and then D. So similarly, we order all these item sets, transactions item set, in the descending order of their spot count. Then from this, we have to generate the header table. If you recall our previous lecture, that in first iteration we have generated the scanned the database and generated frequent one item sets, and from these frequent one item sets we scan the we sort the frequent items into the descending order of their spot count, and then we have to generate the header table. So we have generated the header table. From this header table, we can generate the frequent pattern tree like this. So at the first, we have a root node, which is a null node or empty set. So first we look at the first transaction in which we have B, A, and E as item sets. So first we have B with the count of 1, then we have A with count 1, and then we have E with count 1. So successfully we have represented the transaction ID 100 item sets into FP tree shape. So similarly for the second transaction or TID 200, we can as we have B, so B's spot or B's count is updated to 2 from 1, as along this path you can see we have B and then A and E for first transaction, and then for second transaction we have B. So here we have B, then we have D. So for now we have generated another node from B which is D, and its count is 1. Similarly for third transaction we have BC. We can do the same thing. We just start from the null node or root node, then we go to B and increment its count from 2 to 3, and then add another node which is C, and its count is 1. So again for fourth transaction which is BAD, we just go from root node to B and increment its count, which is 3, and incremented after increment it's 4. Then B, we have to go to A, so A's count is incremented to 2, and then from A we have to go to D, and D's count is incremented to 2. And then for fifth transaction we have to go to A and then to C. As you can see, along this path we have no choice to go to A from root node. That's why we have to add another path or another branch to go for A from the root node. So that's why we have added A along this path, and then C. So then root node to A and C. Similarly, for sixth transaction we have to add B, C. So B's count is 5, and then from B to C, C's count is incremented to 2. Then for AC, for seventh transaction, so again we have to go for along this path, we have to increment A, and similarly we have to increment C. So for the second last transaction, BACE, so we first have to go to B, then we have to go to A, and then from A to C, and C to E, and similarly we can have to increment their counts. And for the last transaction, BACE, so first we have to go to B, then we have to go to A, and then we have to go to C. So this is our final FP tree according to our this header table. So you can verify this FP tree that by verifying their the nodes count value with their stored in the header table. Like B's count is 7, and here it is also 7. A's count is 6, and in the FP tree A's count is 4 along this path and 2 along this path, and if we sum these together it's 6. And similarly for C, its count is 6, so C count 2 along this path, 2 along this path, and 2 along this path, and if we sum up these together its result is 6, so it's again verified. Similarly for D, so D's count is 2 along this path, so it's okay. And similarly for E's sport, which is 2, so it's 1 along this path and 1 along this path, so it is verified that we have constructed the tree accurately. So after constructing the FP tree, so as you know, this is what we have constructed till now. So after constructing the FP tree, we need to construct our database. In the database, check for the least sport count. What is the least sport count? In this case is E. E has sport count of 2. So however D is also 2, so you can take anyone, it's your choice. I am taking E. So now go for your FP tree. Where is E? You need to check, like E occurs here and E occurs here, so we have to traverse from root node to this E node. So from B, A, E, so along this path B and A, the count of E node is 1, and so for along this path B, C, sorry, B, A, C and E, so along this path is 1. So don't confuse with this, and this is other path. This is not the the direct path. This is dotted line just to show the uh, overall value of the C. As we go from here, C is 2, and then from this C to this, these are just showing the uh, connection of the particular node with its occurrences. Like you can see here, A is 4, then A is 2, and B is 7, then B, its connection is nowhere, and E is 1 and its connection is this. So this is not the path of the tree. These dotted line just to show the the occurrences of a particular node in the tree. So for the BAC, its value is 1. So what is the the spot or total count of A, B and C in this conditional frequent pattern base? You get B with spot with count of 2 and A with count of 2. As you know, B occurs in both transactions or both paths, and both paths have 1 value, so that's why B has 2 and A has 2 count in this frequent pattern conditional pattern base. But if we look at C, C occurs only once in one path, so that's why, as you know, the minimum support for our scenario is 2, so that's why we cannot consider C further. So after getting conditional frequent pattern tree, we need to generate frequent patterns. For that we need to make joins with the source item. So we need to join these conditional frequent pattern tree with the the source item, like B, E with count of 2 and AE with count of 2, and then we join these together with the source item, which gives us B, A and E with the count of 2. So then for the next least spot count item set item, which is D, we need to traverse from the root node to the D path. So one time if we look up towards the from D node to root node, we have B and A, and its count is 1 for this path and 1 for this path. It's 1. It's 1. So B and A with the D value of 1, and the second path is B and its value is 1. So after generating conditional frequent pattern basis, we just need to get the total count of each item. So A has 1, so it is discarded because it is less than the minimum support threshold. So B has the total count of 2. So after that we need to generate frequent patterns. So for that reason we need to make joins of these conditional items in the conditional frequent pattern tree with the source item. So with this we get only BD with the support of 2. Similarly we get go for C, and we need to traverse the paths of C from the root node. So 1 times we get B, and A to C with this port of 2, then only B to C with this port of 2, and then from A to C with this port of 2. So we get the frequent items in the conditional frequent pattern tree, which is B4, as it occurs in this transaction and in this path and in this path, which is this path and this path. So total is 4. And similarly for A2, as it occurs in this path, then this path of C, which is A2, and for this path of C we get this A2. So you people can say that why we cannot join these two to get A4, as we had joined B4 in these two cases. So this is because that this A2 is along another path like this, in this path, but these B's occurs along the same path of this side of the tree. So that's why we have joined B, but we cannot join A, because these A2s occurs along this path and these A2s occurs along this path of the tree. So that's why we keep them separate. So keep this thing in mind. So after that we need to construct the frequent patterns from this conditional frequent pattern tree and making joins of these with the source item. So BC we get 4, then for AC we get 4, like this. A2 and A2 we get AC of 4, and then for this BAC we get BAC2. So now again a tricky point, like in this case when we join these two items together with E, we write BA and E with this port of 2, but in this case we have these two items together like B with 4 and A with 2. Now we have different counts, but in the first case we have the same count. That's why we had written the value 2, but in this case we have 4 and 2. So in that case, when we have different counts of the values in the same set, so in that case we have to write the minimum value, like in this case we have written here 2. So then for the next item set A, we had paths from BA with the 4 and other, this is the first node from the root node, so there is no path from there. So that's why we get only B4. So when we get conditional frequent pattern tree, it occurs 4 times, and when we join this with the source item, we get BA with 4. So again for the last item, which is B, which is the first item from the root node, so here we have no conditional frequent pattern base or no the path, so that's why it's empty. So these items are the frequent item sets. These all are frequent item sets, like BE, which is frequent item set of length 2 with the spot count of 2, AE as a frequent item set of length 2 with the 2 spot count. Similarly, BAE is the frequent item set of length 3 with spot count of 2. Similarly, if we talk about this item set, we have frequent BC as a frequent item set of length 2 with the support count of 4. Similarly, these all are frequent item sets. So if we compare this FP tree to the a priori algorithm, in FP growth algorithm or in FP growth tree, we had generated only those items which are frequent item sets. But in, if you recall the a priori algorithm, in that we first generate candidate item sets, then we scan the database to check the counts of the candidate item sets, and then we discard the item sets from the candidate item sets table to get the frequent item sets, and then we again make the candidate item sets of the k plus 1 length, and this process continues. So this is very expensive. So in comparison to the a priori algorithm, frequent pattern approach or method is very uh, you know uh, less expensive to generate frequent patterns. So once we generate the frequent patterns or mine the frequent patterns from the transactions or transaction database, it is straightforward to generate association rules from the mined frequent patterns or strong association rules. So where strong association rules satisfies both minimum support and minimum confidence, which is done using this equation, the confidence A implies B, which is the conditional probability for B given A, which can be written as support count of A union B, which is the number of transactions containing the item sets A and B together, and divided by the support count of A, which is the number of transactions containing the item set A. So before that, we have to follow these two steps in order to generate the association rules. After generating the association rules, we have to check the confidence of the association rule in order to check the interestingness or importance of that rule. So from the frequent item set I, we have to generate all its non-empty subsets in the first step, and in the second step we have to take the minus, like we have to write the association rule like this, like S, which is the subset of I, which is the the subset of I implies I minus S. Like if we talk about A and B, then its subset is A, another subset, non-empty subset is B. So for this we have to take I minus S. So I minus S is when we minus this S from this I, we get only B. Similarly for this, we get only A. So for every non-empty subset S of I, output the rules. We have to generate the rules like this, as we have represented here. So if support divided by support of I, what is the support of I? Support of the total subset or support of the total frequent item set divided by the support of S. What is the support of S? Support of this S. Keep in mind, support of total item set, frequent item set, divided by the support of S, support of subset. If this thing is greater than or equal to minimum confidence value, where minimum confidence is the minimum confidence threshold, then that rule is interesting or good. So let's just uh, apply this on our frequent item set. Like this is our frequent item set. So what are the association rules that can be generated from this X, which is the frequent item set? So first step, we have to generate non-empty subsets of this frequent item sets. So the non-empty subset of this item set are AB, AE, BE, A, B and E. These all are non-empty subsets of this frequent item set. And what is the next step? Next step is we have to generate these are S. So now we have to calculate, sorry, this is S. We have to calculate I minus S to make rules like this. So AB, so what is the difference? I minus S is E. So we get this A, B implies E. Then for the second case we get AE implies B. For the third rule, which third rule is BE implies A implies BE, B implies AE and E implies AB. So what is the meaning of this rule? This rule says that if A and B items are purchased together, what is the confidence that a person can also buy an item E? Similarly for this, if a customer buys an item set A, what is the confidence or what is the support that that customer also buy B and E in that transaction? So what is the confidence of this first rule? So first we have to calculate the support of this. So first we have to go to our transactional database. Sorry for inconvenience. So I'm just putting this table onto that slide. So what is the support of this? The support of ABE. AB occurs once in the first transaction, then it occurs together in this second last transaction. So the support for the item I, frequent item set I is 2. So what is the support of this SAB? As you know, how can we calculate the support? The confidence of the rule. We have to calculate the support of I, which is frequent item, and we have to divide this by the support of the subset of the frequent item set. So this is the subset of the frequent item set. So what is the support of AB? AB occurs in this transaction together, in this transaction, in this and in this. So which is total 4. So the confidence for this first rule is 2 by 4, which is 50%. Similarly for rule second, the support of the item set remains same for all the rules because we are using the same frequent item set. So the support of the S or the left hand side of the rule, which is AE. So AE occurs in first transaction, then AE occurs in the 8th transaction. So the total count is 2. So the total confidence for this rule is 100%. So similarly, you can calculate the confidence for all the other rules. Like if you talk about the second last rule, which is B implies A and E. So this support of frequent item set I is 2. So we what is the support of subset of the frequent item set, which is B? So B occurs in these two transactions, in this transaction, in this, and these two. So 2, 3, 4, 5 and 6. Sorry, one time in this, 1, 2, 3, 4, 5, 6 and 7. So 2 by 7, which is 29%. So the confidence for this rule is 29%. Okay, so if we consider the minimum confidence threshold to 70%, then according to this scenario, we have only 3 rules that are good or interesting for our scenario, which is the rule number 2, rule 3 and rule the 6th rule. So these rules are interesting according to the support of 70%. But if we consider the minimum confidence to 50%, then only these two rules are discarded, and other 4 rules will be considered interesting or important rules, or you can say these 4 rules are useful. So the value of support count or the confidence threshold will be chosen by the expert of a specific domain. So that's it for today's lecture. Thank you.